2.1 is going to be about functions. Functions are a relationship where each input x has only one matching output y. So we have this little flow chart here to kind of help us get started. So it says, is a value of x repeated? If it's repeated, if it's not repeated, you know it's a function. If it is, then we have to decide if the y values are the same each time. If they are, then it's still a function. But if they're not, then it's not a function. So x can't cheat. X can't be with more than one y. So looking here, this first one, we check to see if we have any x's that repeat. And we do, because remember every ordered pair is x comma y. But this one repeats, and it's with a different y. So it's cheating. So it's not a function. I do the same thing here. I look through, this x is used twice, but it's used with the same y, so it's not cheating. That's okay. So this is a function. Looking here, I do have an x that's repeated, and it's repeated with two different y's. That's not okay. So that is not a function. And then here, these are your x's, these are your y's. Let's put x and y, or input and output. Here, 2 is going to 1, 4 is going to 3, 6 is going to 2, 1 is going to 6. Each x goes to a different y, so this is a function. Here, negative 3 goes to 2, negative 8 goes to 2, 2 goes to 7, 0 goes to 7. So 0 doesn't go to two different places. 2 doesn't go to two different places. Negative 8 doesn't go to two different places, and negative 3 doesn't go to two different places. So this is okay. Even though they're both going to the same one, you can repeat y's. You just can't repeat x's with different y's. So this is a function. And we can think if we wrote this out as ordered pairs, that would be negative 3, 2, negative 8, 2, 2, 7. Oh, it's messy, I'm sorry. And 0, 7. So if we were to just look at the x's, none of these x's ever repeat, so it's fine. So if you can't see that from here, just write it out as ordered pairs, and then check your x's. All right, now let's talk about how to tell from a graph. So looking at a graph, we're going to check for a vertical line test. To use a vertical line test, you run an imaginary vertical line, or your pencil, across the graph. If the vertical line ever touches the graph in more than one place, that means an x is going to two different y's. Okay, so that means that the graph is not a function. If the vertical line always touches the graph in only one location, then the graph is a function. So looking here, we're going to think about our vertical lines. Remember, vertical are up and down. And if I drew vertical lines here, this would only cross, it would only cross this graph at one point at a time. We'll cross here, or here, or here, or here. So this is a function. Here, however, if I drew a line through here, it's crossing twice. That's not okay. This is not a function. Because it would cross in both of these locations. Here, I could draw as many vertical lines as I want, and each one is only going to cross one time. So this is a function. The same with this. I can draw a vertical line, and it's only going to cross the curve once. So this is a function. So when they lay on their side like this, that I can draw a line through it more than once. In fact, this one crosses 1, 2, 3 times. This is not a function. Sorry. All right, so remember, Lay your pencil or imaginary line and drag it across the graph. If it crosses the graph more than once, it's not a function. If it only crosses once, it is. Straight lines and parabolas, those are always going to be functions. Unless they're on their side like this, that's when it's not going to be a function. And the only other thing you need to know for this lesson is how to evaluate a function. So we have an input and an output. You put in an x and see what you get out for y. So for instance, here's a function. It says f of x equals 2x minus 1. Well, f of x is really just your output. It's a fancy way of writing y. So this is y equals 2x minus 1. So for instance, if I were to put in 1, I put 1 in the spot and say 2 times 1 is 2 minus 1 is 1. So I would get out 1. So f of 1 would equal 1. What if I put in 3? If I put in 3 here, I put 3 in my machine and see what I get out. So my machine's going to take 2 times 3, which is 6, minus 1 is 5. So f of 3 is 5. So trying this next one down here, I have g of x equals x squared minus 5. Find g of negative 1. That means I'm going to take, and everywhere I see an x, I'm going to put a negative 1. Now remember, this is just a fancy y. This is just a label, so leave it alone. G of negative 1 is what we're finding. Equals negative 1 squared. Negative 1 times negative 1 is positive 1. Minus 5. So g of negative 1 is 1 minus 5, or negative 4. And that's done. All right, come down here and we'll do one more. We have f of x equals negative 3x plus 2. We want to, or sorry, h of x. We want to know h of 10, so that means everywhere there's an x, we're going to put 10. Remember, this is just a fancy y. This is just a label. So we're not going to change that. We're going to plug 10 in over here. And now I have negative 3 times 10 is negative 30. Plus 2 is negative 28. So my final answer is h of 10 equals negative 28. And that's function notation. Please let me know if you need any help with the 2.1 assignment.